Hey guys.
Hello!
So we're back with another project here.
Yes.
I didn't make this. I have no idea what's going on.
Okay. So this is the compass module, and it is it's a 3-axis.
What's a compass module?
It can tell you pretty much, well, it measures the magnetic field of the Earth and can tell you like your heading, whether you're going north, south, east, west, what degree you're going, and yeah. And then you can use that to do a number of things. So this one is the 3-axis compass module, available again from Parallax. And normally I've been making XB wireless things with this. I can put the code up for that. It's pretty easy if you've already worked through the other types of wireless modules that I have. So this one I just wanted actually to show what you could do in terms of calibration. And I hate calibration, but I thought we'd do it anyway. So it looks kind of like a jumble of wires, but it's actually...
Can you show us the side of it?
Pretty simple, sure. So this is just a parallax servo, a continuous rotation servo. It means it can go 360 degrees. This is a perf board that Whisker, worked on to get a bunch of headers.
I guess so.
Yeah.
I did that a long time ago.
Yep. And this was for the OWL project, where I wanted the servo to go 5 degrees based on what the compass told it, and every 5 degrees the ping sensor, or a ping sensor, would get a measurement.
So the servo would rotate and the compass would pick up that the degrees had changed so many, and it would try to jump in 5-degree increments around in a circle?
Correct.
Okay,
and then it would
you're not doing that here?
No. This is actually, I wanted to show, for those who wanted to have their robot or whatever, always calibrate to north. So always return to north no matter where you were. And so all it is the parallax servo, this little adapter board that Whisker made, the compass module on a header, and these, I guess, header wires are connected. 2 of them are to the clock and data line. It's an I2C module, and 2 of these are to ground and power. So VN can take from 2.7 to 6.5 volts. So I have it going into the 5-volt line on my prop BOE. Okay, and then the servo is just hooked into a servo header on the prop BOE board. So that was pretty easy too. And of course, these green and yellow wire lines go to the serial clock and data line pins on the prop. So, yeah. So the one thing about the servo, when I was working the code up for this, because actually the code is new to me, is that the servo would like putts. They go put. And I looked at the code, I tested old code that I knew worked, and it didn't work. Like, it was pretty actually frustrating. And then Whisker said, well, do you have enough power? And I was like, well, I'm an idiot. So we got an Energizer battery, a 9-volt battery. Normally I have, I think it's just like a 7.5 wall wart that I plug into this, which is probably why I forgot about the extra power. And then I have the USB connected to the computer for programming it and whatnot. But note, servos do take quite a bit of power. So make sure you have like a little extra juice for it. Otherwise, it'll,
USB can't source enough current to run a servo, so she was trying to source it off of the USB, and that was causing the microcontroller to brown out and reboot.
Yep.
So it was booting up, and then it turned the servo just a tiny bit, and then that would crash the microcontroller, and then it would just reboot again, because now its current is fine because the server's off. And it just went into that cycle, so it was going zzz, 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 zzz.
So annoying. So annoying. So, yeah, that's pretty simple. All you have to do is connect 4 pins.
Now that you've spent 5 minutes talking about what we're not doing.
Oh, right, sorry. Haha. So I'm going to go ahead and turn this on, and the code is already in, and you're going to see that if it So here is, I guess, our compass, and that way is north. So if this chip is facing this side, then the compass will, or the servo will try to rotate that way. If the compass is facing a degree on this side, then the servo will try to make the compass go that way, to always face north. Okay? Okay.
So it's essentially a feedback loop.
Yep. And then it stops.
And it'll go right back the same direction.
Yep. And you could make it go just in one direction if you really wanted to.
You can make it go a lot faster too.
Yeah, you can. I just wanted to do this so that it wouldn't overshoot and then,
Yeah.
you know, freak out and spin out of control because of all these wires. So no matter what, and like I imagine you can make a wireless version of this, but you couldn't have essentially a digital compass if you don't have like a phone on you. So yeah, all that for this. But once you get this, like you can figure out how to ramp it so that if, for instance, if this is facing south,
The closer it gets, the slower it goes.
correct. Yep. And I tried to do that, but I was just like, meh. I'll just show the basics, and then if people want to mess around with it, then I haven't stolen their thunder.
Okay.
So.
One thing to note with compass modules is they work on the magnetic field of the Earth.
Yep.
So if they get anywhere near a magnet,
Yep.
you'll get interference. And
Yep.
sometimes you can get interference by having them too close to the magnets in a servo.
Or
So
yeah,
you got to have it stood off
exactly.
enough.
Yeah. So part of the thing is these compass modules will always be, I guess, influenced by any magnetic fields in their area. So if it's in like a lot of electronics, then you have to make sure you allow for some error adjustment. So here it's plus or minus 5. So if the compass sees that it's at 355 degrees, then it's willing to stop. If it sees that it's at 5 degrees, then it's willing to stop, with 0 being north. So.
Okay, well,
Okay.
I hope you guys found this useful and maybe inspiring for some little addition onto a project.
Hope so.
That's it for us. We'll be back next week.
Ciao.
Bye.
We post videos all the time, so don't forget to subscribe and follow us on Twitter at TYMKRS.